Pythagoras theorem. So you know definition for Pythagoras theorem. Pythagoras theorem in a right angled triangle, square of the hypotenuse is equal to sum of the squares of the other two sides. For example, you consider a right angled triangle. Right angle at A, here B, here C. As per the theorem, in a right angle triangle, square of the hypotenuse, hypotenuse opposite of right angle. Square of the hypotenuse is equal to sum of the squares of the other two sides. Sum of the squares of the other two sides. Sum of the so other two sides AB and AC. AB and AC. Okay. This is the thing to prove. Okay. To prove AB square plus AC square equal to BC square. Okay. Simple proof only. Listen here. Do one thing. Construct. Okay. Construction. Okay. Draw AD perpendicular to BC. Okay. Draw a straight line from A to BC. Okay. Which is perpendicular to BC. So this point you can take it as D. Okay. So you have to do this small construction alone. Then you can observe here. Okay. In this triangle ABC, you will get three triangles. Triangle name is ABC. There is a big triangle. ABD, that is small triangle. ADC, that is a medium triangle. Okay, there are three triangles are there. Remember, one is ABC, ABD and ADC. So in it, you remember, you can take this angle as angle B as you can take it as theta. If you take this angle as theta, what about angle C? You know very well, one is a right angle, sum of these two angles will be 90 degree. So remaining this angle will be 90 degree minus theta. Now add this angle ABC, surely it will be 180 degree. Sum of angles of a interior angle is 180 degree. Okay, so interior angles of a triangle is 180 degree, you check it. Okay, now if it is theta, clear this is 90 degree. What about this value? Okay, so this is 90 degree minus theta. Now come to this triangle ADC. Here 90 degree minus theta, this is 90 degree. What about this? This clearly it is theta. Now you can check 90 degree minus theta plus theta, that is 90 degree only. Okay, remember this alone very well. Now let me write. So triangle, okay, similar to triangle. Okay, so entire triangle, let me take entire three triangles. Okay, one is, okay, name of big triangle is ABC. Small triangle is ABD, medium triangle is ADC. Okay, let me take these three triangles. Okay, so I'm sure these three triangles are similar. How they are similar? Okay, see here. In ABC, 90 degrees at A. In the small triangle, 90 degree at D. This medium triangle, 90 degree at D. Then come for angle theta. In ABC, big triangle, theta is at B. Small triangle, theta is at B. Okay. Then medium size triangle, theta is at A. Then missing angle, okay, that is 90 degree minus theta. Okay, in big triangle, 90 degree minus theta is here C. In small triangle, 90 degree is at 90 degree minus theta at A. In medium size triangle, 90 degree minus theta is, that is C. Okay, by angle criterion and angle criterion. Okay, triple A criterion. So I'm sure these three triangles are similar. Next step, you can see here. If two triangles are similar, okay, let me take these two triangles first. These two triangles are similar. I'm sure their sides are in proportional. You know that result here. Okay, how can we write it in proportional? First one you can see AB by DB. AB by DB. AB by DB is equal to BC by BA. again is equal to, see, AC by DA. AC by DA. See, I need AB square or AC square. Any one I need. Okay, left hand side. So you don't add panna, only BC square varum. Okay, so here you can take AB. Here AB is there. You can take in this two. If I take this two, just to send it here, value of AB square is BC into BD. You can take it as equation number 1. Comparing. Okay, so AB square part completed. I need AC square. Where are the AC? AC you can check. Okay, here AC is there. Again here AC is there. Now you check these two. These two triangles are similar. You can write it in proportional. See, AB by first two, AB by DA. Next one, BC by AC. Then one more, your AC by DC. Okay, now you can take these two or that two. Okay, but where is AC? For AC, this and this. These two you can take. If I take value of AC square is BC into DC. AB square is there, AC square is there. If I add these two, okay, I should get BC square. That is the result to prove. Okay, now what is the AB square plus AC square? Okay, now let me add AB square value plus AC square value. AB square value is BC into BD plus adding, okay, adding equation 1 and 2. Remember, adding equation 1 and 2. This is the process we are doing. Next, AC square value of AC square is BC into DC. That is value. Now, right hand side you have to prove BC square. So, small modification we have to do. Here BC BD, here BC DC. You take BC outside. If I take BC outside, inside there will be BD plus DC. BD plus DC. Here it is BC is there. What is the value of BD plus DC? B to D, D to C, that is the BC. That is the BC. Okay, the result is here it is a BC square. Okay, so AB square plus AC square equal to BC square. Okay, so AB square plus AC square is equal to BC square. So this is the theorem for Pythagoras theorem. In a right angled triangle, square of the hypotenuse is equal to sum of the squares of the other two sides. Very simple only, please note it.